Okay. Welcome, everybody. It's my great pleasure to introduce you here for this presentation by Terry Chapin. He comes to us from the University of Alaska Fairbanks. Terry has been reasonably active professionally. He's published something over 300 papers that have been cited over 27,000 times. Just to be clear, that makes him one of the most cited scientists in the world. 9 or 10 books, a couple of which we use here at Dartmouth College, a brand new one related to his topic today that I'll bet will be in use in a Dartmouth course anytime now. He's made seminal contributions to plant physiological ecology, nutrition of plants, plant defense theory, community ecology, succession theory, among those topics, ecosystem science, and now Terry is showing us the way in this thing we call sustainability science. And his work in developing an IGERT program on that topic in Alaska has been a powerful role model for the one that we're developing here. And, let's see, he's a pretty hot fiddle player. He's a member of the National Academy of Sciences, and there's some other stuff like that too. But for a couple hundred people probably, Terry has been a very, very important person as a role model and mentor. I count myself to be among those. I've been doing a poll among many of those people over the years, and so far as any of us can tell, no one has ever had a conversation with Terry that he ended. It's amazing. It's truly amazing. We just don't know how he does that on top of all that other stuff too. And Terry, please.
Thanks, Matt. It's really exciting to be here. I really appreciate the chance to talk to all of the IGERT folks today. You guys have an amazing program here, an amazing group of scholars. I really appreciate the opportunity to be able to visit with you. So today what I'd like to talk about is sustainability science and how we think about sustainability in the context of a rapidly changing world. One of the things that's really striking about so many things in the world today is that they're changing rapidly and that they're changing in a very directional way. And one of the things that's striking about this set of diagrams is that they all show basically the same pattern, directional changes in each of these measurements. And then in addition that there's been a huge acceleration since about 1950. And if we look at the general categories of things here, there are various drivers of most of the processes that are important at a global scale. There are changes in the way in which social and ecological systems work, and changes in a variety of other parameters, the resource use, major disasters, our exploitation of resources. So many of the things that we care about as a society or things that we might care about as ecologists are changing in some very, very fundamental ways. So this has some important implications for sustainability. So if the world were, usually when we think about sustainability, we think of it as in the situation where the future will be very much like the past. And so in this sort of a construct, sustainability is really a pretty straightforward concept. If you just keep things going on track the way they have been in the past, then you've got a sustainable trajectory for the future. But how in the world do you think about sustainability when the world's directionally changing? It's clear that we can't keep things the way they have been in the past. Things are changing and will continue to change. So how do we think about sustainably managing ecosystems or maintaining a sustainable trajectory for society under these conditions? And that's what I'd like to talk about today. Now, if we think about this in the long-term context of the last 100,000 years up to the present, these are the changes in temperature here on this axis that have occurred over that period of time. And to me, the most interesting thing about this graph is that over the last 10,000 years, the climate has been incredibly stable. This is the period of time since agriculture began, since all of the great civilizations were formed. This is the time when societies all around the world have made major changes, major developments in the sort of things that we think of as perhaps great advances in societies. And yet, if we look at temperature now, we're moving outside of that stability domain pretty substantially. What's likely to happen to societal systems, to ecosystems, if we move outside of this stability domain? So if we're undertaking activities that are modifying the climate systems in ways that it might change from its recent patterns, we're really messing with things at a scale that could have huge societal implications, and we don't really fully understand the consequences of the changes that we're causing. So we're not only changing climate. This figure shows some of the changes that are happening in a variety of different things that are likely to be important to society. So each of these spokes on this wheel represents a way in which society is modifying things at global scales. And a group of scientists had guessed at what would be a safe limit to the changes where society could maintain a more or less comfortable relationship with the biosphere. And if we were to exceed these limits, then we might be causing serious changes that might change the way in which the Earth system functions. And so we can see that for several of these things, such as nitrogen flow, the loss of biodiversity, the rate of climate change, we're exceeding the limits of what many scientists would view as causing serious changes in the Earth system. So in the case of biodiversity loss, the rates of extinction are probably between 100 and 1,000-fold higher than they were prehistorically. In the case of nitrogen flows, the total inputs of nitrogen to the world's ecosystems are twice what they were prehistorically as a result of human inputs of nitrogen in the form of fertilizers and combustion of fossil fuels. And climate change is another thing that's really pushing the envelope of the safe ranges of a stable situation for society. And we're pushing we're approaching limits on several other things as well. So I think human activities are modifying the Earth system in ways that are changing directionally and which have potentially massive implications for the functioning of the global system. So what I'd like to talk about today is just to discuss how this plays out in Alaska. Many of these changes that are happening are particularly pronounced at high latitudes, and so Alaska is one of those places that's warming as rapidly as almost any place on the planet. So if you want to understand some of the ecological and societal implications of this, that's a good place to think about it. And these are the changes in temperature that we've seen over the historical record in Alaska and for spring temperatures. And then these are the changes that are projected for the rest of this century. And one of the things you can see is the temperature is highly variable year to year, but that despite this variability, we can see a clear trend since the 1970s, and that this trend is projected to continue regardless of the differences in assumptions made by different climate models. So the way that this comes home to me is that if I look at what the average temperatures are likely to be in the middle of the century, that's the temperatures that we or our children are likely to experience. the average temperatures are going to be as warm as the warmest temperatures we've experienced historically. By the end of the century, the coolest temperatures are going to be similar to the warmest temperatures that we've experienced historically. So that gives you you all have a sense of what a cool year is versus a warm year. And if the years that we're going to be experiencing in the future are likely to be that much warmer than what we experience currently, that has really important implications. And I think each of us has a sense for what that means to us personally and for what it means to the to various ecosystem processes that we might observe around us. So this has had effects in Alaska, and I just want to show you some pictures of some of these. So in places where one of the effects has been the drying up of lakes in many parts of Alaska. So you can see that if you look at the photograph of any aerial photograph of any particular lakes, they've gotten smaller through time because we've had warmer temperatures, more evaporation, and not much change in precipitation. In other places where there's ice-rich permafrost, permafrost has thawed. So this is a picture of what you see when you leave the Fairbanks airport and fly south from Fairbanks. You see places where birch forests have changed into wetlands. There's places in southern Alaska where there have been massive insect outbreaks. This is on the Kenai Peninsula with bark beetle outbreaks. Incidentally, almost all of the tree species in interior Alaska are undergoing insect outbreaks that were not present a decade ago. Forest fires are becoming more extensive than they were in the past. And so if we look at the historical record of forest fires and the projected changes, the historical record, there's partly a record that where the aerial extent of forests, which should be written out here, has been measured, and then that's been reconstructed through time through using stand age reconstructions, and then the projections are based on fire models that are associated with the changes in temperature that you saw earlier. And if we use the same sort of metrics of what's likely to happen mid-century in terms of average area burned compared, that's going to be similar to the area burned in the most extreme years in the historical record. And by the end of the century, those years that have relatively low area burned are going to be similar to those years that are extremely high at present. So this suggests a massive change in fire regime for interior Alaska. Again, I apologize for lack of axes here, but this shows the historical changes in the abundance of spruce and the abundance of deciduous forests in interior Alaska. This is using a forest vegetation model that's been developed by Scott Rupp. And what his projections are that as a result of changes in fire regime, there'll be a large decrease in the abundance of spruce forest and an increase in the abundance of deciduous forest. So when we think about the boreal forest, we think of this as being a conifer-dominated biome. This is a biome where conifer trees like spruce are the predominant feature of the landscape. According to these projections, that will no longer be the case. And this is 1970, so that's this switchover is likely to be occurring within our lifetimes. So here's a biome that's undergoing major structural change and likely to do it quite rapidly. So what I've told you then is that the ecology of Alaska is changing rapidly, and it's projected to change even more dramatically on timescales that we and our children are going to experience. This is a map that my wife pointed out to me the similarity of these two maps. And what it shows is that if you look at the distribution of the ecosystems of Alaska, and if you look at the distribution of the language groups or the cultures of Alaska, it's virtually identical. It's virtually the same map. What it says is that these cultures are extremely tightly tied to their ecology and have been for thousands of years. So if we change the ecology of Alaska, what does that mean for the cultures of Alaska? These are cultures where people are still very much tied to the places where they live. I think this is one of the most serious issues with respect to climate change that we face throughout many parts of the world, and where it's likely to become an increasingly important issue in places like Alaska. So what do we know about climate change in terms of variability? We know that ecosystems or social ecological systems fluctuate have certain ranges of tolerance, a lower limit of tolerance, say, of some environmental variables such as temperature, and an upper limit of tolerance, and that these environmental variables or whatever driving variable may change through time, but that as long as it remains within a certain range of tolerance, that the functioning of this system is likely to persist through time, and we can withstand a certain amount of variability. But what if we get a directional change in climate, such as we are seeing with climate warming? What if climate warming becomes more variable, as we're seeing with climate change? What if we're experiencing situations where systems are changing in such a way that perhaps they're losing species diversity and becoming less tolerant, less able to tolerate a certain range of variability, which, as we've seen, we're losing species diversity? Any of these things would likely have the potential to shift these systems outside of their current stability domains. So if we want to think about sustainability in a context of climate change, we need to think not about staying within this stability domain, but think of ways in which we can broaden the envelope of the stability domain, increase the adaptive capacity of this system ecologically, socially, and social ecologically, if we're going to be able to meet the changes that are likely to accompany climate change. So that's an interesting set of challenges, no matter what our discipline of interest is. Here's a diagram that shows how a social ecological system, and I'll just call this a blue box for now, has a certain set of internal dynamics. It responds, these system dynamics may change as a result of changes in drivers. These are changes in external forces on the system. And if the system dynamics change, this has a certain range of potential outcomes. The system may persist. It may change to something radically different as a result of our unintended consequences, or we may be able to actively manage this system in such a way that it changes, but in a way that's potentially beneficial to society. So these are three potential outcomes to the system. If the system's highly resilient, it may persist in its current condition. So one of the issues then is what are the factors that govern the resilience of this system to these perturbations that we're now seeing, these changes that I've told you about. So now let's become more explicit. So some of the changes that are happening in Alaska, for example, are a warming of climate. This is associated with a population increase, largely from immigration from outside the state, which is linked to global population. As a result of both increases in ignitions and warming climate, we have more wildfires. This changes a variety of different ecological variables to which the system is sensitive. And then there's a range of potential ways in which this ecological system can respond. And these involve learning something about how the system is changing and how it's projected to change in the future. Things that we might do to cope with these changes, thinking about ways to innovate, and this might be innovations that occur ecologically or socially, and ways in which the system might adapt, either evolutionarily, ecologically, or socially. And a lot of these, the extent to which we can adjust and adapt to these changes in conditions depend a lot on sort of the internal characteristics of the system and the dynamics of the system. And I'm not going to go into the details of those, but the basic idea is that the way in which this system responds to external forces depends a lot on these internal dynamics that we can understand as a result of studies. And there's several bodies of literature that help us with this. Studies issues of vulnerability, which is the framework for the Intergovernmental Panel of Climate Change and most of the other climate change assessments. The resilience framework, which comes from ecology and basically deals with the degree of flexibility of this system that might enable it to persist. And then issues of adaptation, where there's a rich literature in both ecology and anthropology. And another set of issues that I think we need to begin thinking seriously about is transformability, things that may cause this system either to transform in unintended ways that might not be beneficial, or the ways in which we can shape changes that are inevitable in such a way that that the system may move in a way that's potentially socially desirable. So this is the system that I've been interested in for the last several years, where we have changes in climate that occur globally that propagate down to changes that we experience in Alaska, as you've seen in the slides that I showed you. These alter the structure of ecosystems, and we talked about that, and the fire regime. And so I've become more and more interested in the ways this connects up with local communities. This connects with communities not only because of the interactions between people and fire regime, but also because ecosystems determine the abundance and availability of subsistence resources on which many rural communities in Alaska depend. This is the community of Fort Yukon. It's one of the larger rural communities in Alaska. There's no road connections, no connections to the electrical grid. People get around mainly on the river and on snow machine trails. And so people are very much connected to the world around them. It's different than it used to be in terms of the way in which people interact with the land. 100 years ago, or even 75 years ago, there was a relatively regular seasonal round of activities where people move from summer fish camps to up into the mountains where they'd hunt for caribou, or other places where they'd hunt for moose. And so people would move around the countryside and so that they were able to harvest resources at appropriate times of year. And if an area burned, then people would just adjust this seasonal round and still be able to harvest resources from areas that were at the appropriate successional stage after fire. But now people are consolidated into permanent settlements because of compulsory schooling, because of the luxuries of having electricity and heating and permanent housing and medical availability of medical facilities and all kinds of things that most of us would consider necessities. And so this has really changed the relationship between people and society. So now, or between people and the ecosystems that surround them. Now, if a fire occurs close to the community, that has some different kinds of ecological consequences. So what this shows is changes in the density of animals at various times after wildfire. And what you can, these are patterns that I scribbled out based on conversations with hunters in several different communities. And if I go to talk to fish and game biologists, they draw the same picture. So they had there's the same basic science observations from both sets of observers. And what you see is that moose increase to a maximum about 15 to 30 years after wildfire, and that caribou take much longer to recover because lichens, which are their winter food, take longer to recover. It takes about 80 years for the lichens to come back. So when I show this slide to wildlife managers, they emphasize the importance of maintaining wildfire as part of the natural system. It's been part of the boreal forest for the last 6,000 years. The plants and animals are adapted to wildfire, and if you start taking wildfire out of the system, it changes to something different. So there's been a lot of efforts to maintain wildfire and minimize the amount of suppression activity in rural Alaska. When I show this slide or talk to people in the villages about this, they say, that's a generation before I can teach my kids how to hunt. That's 4 or 5 generations before anything I know about caribou hunting can be passed on to my grandchildren and great-grandchildren. So the opportunities for cultural disconnect when you start having these sorts of gaps that could be caused by wildfire. So wildfire close to a community has a really, really different social impact, even in cases where the ecological impact is identical. So this raises some real questions about how you should manage wildfire in an environment where wildfire is inevitably going to become more frequent. So I'm going to come back to that in a minute. So I'd like to go through several different lenses in which to think about about sustainability in the context of large directional changes in environment. And the first approach is to reduce vulnerability. This, and as I mentioned before, this is the approach that's been taken in climate change assessments, and it's not easy to do, but the concepts are relatively straightforward. You reduce the exposure to hazards and stresses that are causing an impact, and you reduce the sensitivity of the system of concern to these hazards and stresses. And so you might reduce exposure to hazards and stresses by minimizing the known stresses and avoiding new stresses, developing institutions to minimize stresses that are beyond the control that you can exert at a local level, and you manage for projected changes rather than for managing for historical conditions. So that says that conservation biology ought to have a very different view of how they think about sustainability and conservation. In terms of reducing sensitivity, there's lots of ways that social scientists and natural scientists have talked about sustaining and enhancing natural and social capital, and also sustaining and enhancing components of well-being. And there's issues of involving trade-offs among ecosystems and multiple segments of societies. We could talk for an hour about any one of those various ways of reducing ecological sensitivity, but there's some fairly well thought out patterns of how to do this that are often context specific and appropriate. Different sort of strategies are appropriate in different locations. So I would just like to show you one example of a place where we're missing some of the ecological feedbacks, some of the institutions that are needed in order to be able to respond appropriately. And so in the case of climate change, the main driver is human behavior at a global scale. This causes warming at a global scale. That's particularly pronounced at high latitudes. But there's nothing that people or ecosystems at high latitudes can do. There's not a strong feedback to modify human behavior. It doesn't, in a sense, there's very little that we can do in terms of modifying our own behavior that's really going to stop climate change or reduce its rate of occurrence. We have to construct or develop this feedback to global human behavior. So what are some of the ways? So understanding something about the dynamics of the Greenland ice sheet, for example, is something where we could really connect with concerns of the residents of New York City. And this is one of the kinds of things that your IGERT program is exploring. I think that's a great way in which you people can contribute to building a feedback here that's really important. Understanding changes in the well-being of Arctic animals and residents, perhaps by telling this story convincingly, we might influence things that some people choose to do. Some people care about polar bears. Some people care about the opportunities that Arctic residents have or may not have. So in terms of adaptive capacity, one general approach is to just enhance the diversity of options. So maintaining diversity, whether you're talking about ecology, biodiversity, economic diversity, cultural diversity, all of these things sort of increase the options that you have for adjusting to an uncertain but different future than what we've had in the past. Now, one of the challenges in Alaska is that many of the people in interior Alaska, there's a relatively high proportion of these people that have that are below the poverty level, and so this is one of the economic aspects that really constrains opportunities for adapting to change. But it's not as grim as it looks, because many of these people rely on many of their economies are actually built around subsistence. And so they get a lot of food from the country that they don't get from the store. It's not to say that those economic conditions are not serious, but people are really good at being able to cope with local conditions. And this shows the amount of food, subsistence harvest per person in a variety of different communities. Each one of these bars represents a different community, and you can see that each one of these communities relies on a mix of different subsistence resources. And years where one subsistence resource is reduced, people harvest more of another one. So there's opportunities because of this diversity of patterns of subsistence use to be able to cope with some degree of ecological change and some degree of changes in subsistence resources in response to changes in climate. Athabascan people in interior Alaska have always viewed themselves as a salmon people. They've adapted to changes in technology really well. Motorboats, nets, lots of things. Technology is a really good way to be able to adapt to changing conditions. They're also really proud of their ability to adapt to many of the environmental conditions that they're seeing, but they want to know much more clearly what's coming down the pike in terms of things that are likely to affect them. A lot of enhancing adaptive capacity for adapting to the future, I think, involves various ways of social learning. And this involves broadening the problem definition beyond just climate, involves thinking not just about the past, but using scenarios of the future, and then testing understanding through comparative analyses and experiments. So I'm just going to show you one example of ways of one way in which social learning has occurred and has resulted in adaptation. This has to do with sharing networks. Traditionally, families shared food among kin members, and now as Western economy has become part of these villages, there's also sharing that goes on between people who don't have jobs and people that do have jobs. People that have jobs will pay for gas so that somebody else can go out and hunt. People who don't have jobs have the time to go out hunting when the conditions are right for hunting. And so there's a fair amount of sharing that goes on, and oftentimes there's 30%, in general, it seems that about 30% of the people in the village provide 70% of the food. So there's some people who are very active hunters in these communities. So here's a way in which a traditional institution in this community has adapted and taken on a very different pattern. It still fulfills the same function, but the ground rules for this are very different than they used to be. Now, for scenarios, one would project with increasing wildfire, as I mentioned before, that there might be a reduction in caribou habitat and an increase in moose habitat. So you can figure this into projections of what might be likely to happen to subsistence resources in the future. So one of the things we've done with some of these communities is talk about some of the changes that are happening and some of the challenges that face them. So they face challenges in climate, they face an energy crisis in the rising cost of fuel, they face challenges in terms of trying to maintain their cultural ties to the land, their cultural identity in the face of a Western-oriented school system, in the face of many of the other changes that they see. And so the people in the communities often look at these things look for more holistic solutions. So one of the things that we've discussed as a way of dealing with fire regime, for example, is to harvest flammable fuels near the communities and use these as biofuels for heating of public buildings. And we've done some rough calculations that would show that this would be ecologically sustainable for most of the communities. It would be economically viable for most of the communities. And most of the costs of carrying out a program of this sort are the costs of wages, and those wages would be retained locally rather than going outside to buy diesel fuel. But there's huge challenges in terms of just the institutional barriers of working out these sorts of arrangements. So another aspect of increasing adaptive capacity is adapting governance to implement potential solutions. And I want to give you an example here. This is a map of the proportion of hunts by rural residents, and the light gray are the places where urban residents account for most of the hunts in rural landscapes. The only large town in interior Alaska, or the only large towns here, are Fairbanks, Nome, Anchorage, and Juneau. The rest of this is largely rural communities. The places where rural hunters predominate are places where there's very few moose. So in most of rural Alaska, most of the hunting is done by urban hunters. So there's various ways in which policies influence the moose that are harvested by communities. And if there's policies that influence this, there's opportunities to modify these policies in ways that might increase subsistence harvest by local communities. So we've got changes in climate, fire regime, vegetation, and moose that I've already talked about that are inevitably going to change the moose abundance. But then there's predator control policies, there's fire policies, fire habitat management policies, hunting policies, and so forth, that could also influence the availability of moose to rural residents. So I'm optimistic that if we begin thinking about the various opportunities, that there are ways to manage around what seems like some challenging problems. Now, just thinking about fire management, the costs of fighting fires in interior Alaska are rising mainly because of changes that have happened to Alaska from things that are happening elsewhere. We've got a rising human population because of global population rise. We've got climate change, which is due to global human behavior. We've got increased costs of training because of accidents that have happened with firefighting crews in Colorado and elsewhere. And all of these things have caused the cost of firefighting to double in the last 10 years. So what are we going to do in terms of increasing probability of fire, increasing costs of putting out fires? Well, we could think of this as two ways in which we could maintain the resilience of two aspects of the system. If we were to try to maintain the same fire regime today, despite the increasing flammability of vegetation as the climate warms, we estimate that it would require about a 20-fold increase in the cost of firefighting. Now, if you have climate warming also increasing the flammability of places around Los Angeles or someplace like that, and the national agencies are trying to decide whether to fight fires in Alaska or fight fires in Los Angeles, you can guess what the answer is going to be. Right now, approximately 50% of the budget for the Forest Service goes into fire suppression. They're very close to not being able to manage as an agency for doing anything other than suppressing fires. So we're very close to the tipping point, even with the fire regime today. So An alternative would be to maintain the same budgetary allocation to fire suppression. We just give the same proportion of money to fire suppression. But we've got increasing wildfire risk, we've got rising population. So what this means is a smaller and smaller proportion of the landscape that can be where people can be protected from wildfires. That's also likely to be an unpopular trend. So another option is to think, well, maybe we just need a very different kind of fire regime on the landscape than we've had historically. Maybe we shouldn't be looking to try to maintain either an economic approach or an ecological approach to sustaining the past fire regime, but we should be actively trying to look at something different. Perhaps by trying to manage fires so that we have many smaller fires and have a much more heterogeneous landscape than what we've had in the past. So that's different. So this is an example of transformation to go towards something different. Sometimes transformations happen to you rather than something that you plan on. So I think there's some strategies that we could take for preparing for and navigating transformations in constructive directions. And this I think is a very new way to be thinking about sustainability. It's sustainability in a very broad sense. It's sustainability by inducing change. So planning for transformations means engaging stakeholders to figure out what the problem is, identifying the thresholds, where do you want to go, identifying barriers, how to get there. And then I think there's ways to prepare you. Many of these things you can do in advance and be prepared for transformations, and then you look for a crisis can be an opportunity to initiate change. Now, most of us can think of crises of one scale or another that are quite likely to happen where we live or work. These are the things that people worry about all of the time. But if you're prepared for those crises and can think of ways in which those can be used to navigate towards some alternative state that might work better under future conditions, then that's one way to think about things. And so this means maintaining a flexible strategy because it's not going to play out the way you think it will, and being transparent so that the effort's not co-opted by some special interest group, and then fostering institutions that draw on resilience and resources from other scales. And then we've already talked about building resilience. So just let me give you another example of thinking about transformations. Sea ice is disappearing in the north. This threatens not only marine mammals, but also coastal communities that depend on those marine mammals for a cultural and a nutritional resource. One of the other things that happens as the sea ice retreats is that salmon are moving north, and they're moving into rivers where they never were before. So maybe salmon are an alternative subsistence resource for some of these communities that have traditionally been dependent on marine mammals. So one conversation that could be had in communities is what's their deepest value that they're trying to sustain? Are they trying to sustain their connections to the land and the sea, or are they trying to sustain their connections to marine mammals? So perhaps we should be thinking about designing marine reserves for a fishery that doesn't exist. Maybe we should be managing stream gravels and recruitment spawning habitat for salmon in a place where the salmon don't yet exist as we think about managing oil fields. So these are thinking about managing for transformation. Right now there's no vested interest that would oppose setting up reserves in a place like this for salmon, to maintain salmon. And so wouldn't be a lot of political opposition to something like that. So one of the things I've become concerned about is that this is just a snapshot of a very tiny place on our planet. And if you think about the place where you are, or the places where you grew up, or the places that you care about, I think you could probably tell a similar story with different actors, different players, different drivers, but it's a situation that's playing out throughout the entire planet. I think we're on a trajectory of a very unfavorable relationship between society and the biosphere, the planet on which we live, our life support system. So I think there's a really urgent need, but also some tremendous opportunities to turn around this relationship. We've never had a more supportive administration in terms of thinking about opportunities to do this. The Stern report has shown the economic costs of climate change and shown that there are real economic advantages of slowing the rates of climate change now while we have a chance to do so. And there's many other ways in which where I think there's opportunities to progress at larger scales. And I think there's ways in which we can do this at any scale at which we might be interested in studying or taking action, whether these are local, regional, or larger scales. So Alaska is a place that's vulnerable to climate change. It has some really important sources of resilience, and many of these are in local people who you might not think of as having a lot of resources to cope with change. There's opportunities for transformations that can move in positive directions despite the changes that are occurring. And I think these ideas of ecological stewardship, thinking about shaping the changes for the future, provide some real opportunities and some guidelines for moving in directions that we might want to go. So if you have any questions, I'd be glad to, or any comments, I'd be glad to answer them. Thank you. Simone.
How would you define resilience, and how does that relate to biodiversity being resilient?
I would define resilience as the capacity of a system to minimize the impacts of perturbations and shocks to a system so that it continue to maintain its more or less normal functions despite these perturbations. And so basically, how can a system be flexible and be able to adjust in response to changes and perturbations? So one of the things that biodiversity can do is just to increase the number of options that are available. It can increase the number of species that can may be able to deal with different kinds of conditions under a changing climate, with different sorts of disturbance regimes. That's a way in which biodiversity can be really important to ecological resilience. And I think economic diversity plays exactly the same role in terms of local economies. Alaska, for example, has 90% of its state revenue coming from one industry. And it's not very likely to be resilient to changes in the energy industry. So I think diversity plays out in many different ways that are logical in a very general sense. Yes.
I was wondering if you could, if you had any thoughts on whether or not rapid climate change or rapid warming will reduce the already limited acceptance of traditional ecological knowledge of Alaska Native communities, or what that has in store for the future of the integration of Alaska Natives into discussions of climate change or climate science.
I think Alaska Native culture has a huge opportunity to contribute to solutions, to adaptive solutions. For one thing, one of the defining characteristics for me is that it's a very holistic perspective. It's not stovepiped into energy issues, ecological issues, cultural issues. It's all part of the same thing. And I think that's the solution that we face with the changes that are happening globally and nationally. Is it's a suite of interrelated problems, and I think a lot of the solutions are going to be grappling with these problems in a holistic way. And so I think just the general philosophy and approach of Alaska Natives to their lives is a lesson that we can learn from. And then in terms of specifics, they've got the best observation network available in Alaska on the sorts of ecological conditions that society cares about most strongly. So they're just as a result of being long-term observers on the land. For example, they were the Alaska Natives were the ones to point out that the landscape is drying before anybody noticed on satellite images. They're the ones to talk about increased parasitism of salmon. And I could go on and give you a list of dozens of examples where they've been the observers that are on the front lines of climate change and seeing it happen and reporting it. So I think there's wonderful opportunities there for a constructive dialogue. That's not the way it's happened in the past. Yes?
So I really like the idea that we can't really try to keep things the way they are, and we have to be very adaptable to it. And your example about people looking for sea mammals and maybe switching on to salmon that are moving into the area, what it sort of brings to my mind, though, is one of, it may be not possible to actually plan for what you want to do because everything's opportunities. So how optimistic or pessimistic are you about actually planning something for the future and then implementing those kinds of plans? Because it seems like a lot of what you're talking about is being adaptable and responding to whatever happens. And
that's right.
Which means you can't plan for what you should be doing, except to go, we know we're going to have to do something, we're going to have to change, and basically that's as much as you can say about it.
In a sense, that's what we do every day. We never know what's going to happen next day. Each of us as individuals or as larger units never know what's happening. So we're always adjusting to surprises. Now, I think through climate change science, we can identify some of the very likely trajectories that are going to happen. And we can use those trajectories of expected change as our targets for what we might expect, rather than our experience with what's happened in the past. So I think there's some ways in which scientific tools can help us adapt. We certainly won't be able to predict or expect all of the surprises that are coming, but we've never been able to do that in the past either. So I think there's ways in which we can adjust. We just need to be aware that we need to be flexible and having our eyes on the future. It also might be a good time to point out that adaptation to future change and mitigation of rates of change are two parts of the same problem. The more we can reduce the rates of climate change, the less extreme will be the changes that will occur in the future. And so I think as long as we think of those being two parts of the same issue, then I think we can begin to move forward if society can begin to take this problem seriously. Yes?
I don't think I need a microphone. Thank you so much for your talk. It was really interesting, and I have so many questions. So I study climate change, and I'm looking to some extent at these relatively recent climate changes, such as the Little Ice Age and the medieval warm period. And one of the most striking things I saw in your talk was that the map that you showed between the vegetation and the native people in Alaska, and how those are so similar. And I would assume that during the recent medieval warm period and the Little Ice Age, that those vegetation patterns in Alaska and as a result, the people must have changed. And I was wondering if there's any sort of local history passed down through people about how people have adapted to those changes in the past, because they're recent. They're 150 years ago to 1,000 years ago. So there are definitely people.
There is some oral history. For example, there used to be bison in interior Alaska when it was colder. And the last bison remains are about 150 years ago. And so there's some oral history of using bison in some places. So there are some bits of oral history, but not very much. One of the things that's really surprised me and that I don't really understand is that the fire regime has been incredibly constant for the last 6,000 years. It's highly variable year to year, but you don't see a really striking pattern that pulls the Little Ice Age out as being radically different in terms of fire regime. And I would suspect that that would imply that at least the types of forest cover would have been similar through the Little Ice Age.
Okay, I have one question about that then. On your plot that showed the deciduous trees versus the spruce,
Right.
there was a crossover that was projected to happen in the future, but there was also a crossover in the past that was like pre-1990, and there was a big increase there was a trend in the past that I didn't understand.
Oh, that's a good point. That may well be related to Little Ice Age. That's a very good point. Yeah, you might. That's a very good point. You're probably right about that. Thank you. Well, thanks very much.
Thank you, Terry.